Hello guys, welcome to my channel, and in this video I'll explain you article number 2.14 combination of capacitors. So there are two possible ways in which we can combine capacitor. One is series combination and the other one is parallel combination. So let's start. We can combine several capacitor of capacitance C1, C2 up to Cn to obtain a system with some effective capacitance C. Okay, if we are given n number of capacitor, we combine them to form a system of capacitor, and there will be effective capacitance of all the capacitors. The effective capacitance depend on the way the individual capacitors are combined. Okay, and obviously the effective will depends on how we combine the capacitor. Either we combine them in series or in parallel or a combination of both. That will give us the value of the effective capacitance. Two simple possibilities are discussed below. The first possibility is the series combination, that has capacitors in series. You see, in capacitor series, what we'll do, we combine one end of both the capacitor together and one end will be free. That will connect to the battery on any circuit as required. Okay, figure 2.26 shows capacitor C1 and C2 combined in series. The left plate of C1 and the right plate of C2 are connected to two terminals of a battery and have charges Q and minus Q. You see that the left plate of C1, this is the left plate of C1, is connected to and the right plate of C2 are connected to two terminals of the battery. They are connected to the terminals of the battery and having charge Q and minus Q, and this have charge because they are connected to a battery. That means there will be plus Q charge here and minus Q charge on this plate of this capacitor. See, okay. Now it then follows that the right plate of C1 has minus Q and the left plate of C2 has charge Q. Okay, so obviously you see by induction it will have, when I connect it to battery and it has charge Q plus Q, then obviously this will have minus Q charge because of induction. And now similarly here it has a minus Q charge and it will have plus Q charge. How does this will happen? I'll explain you. Suppose I connect this battery. Okay, so what will happen? Suppose the negative charge or electron flows from there. Okay, electron flows from here, minus Q charge is on this plate. Okay, now due to induction, or I can say the electron here will be repelled by the charges that have been accumulated here. Okay, so now this electron will move because of repulsion, they will move to here. Okay, and there will be negative charge. Okay, and in this, because minus Q charge has moved here, so there will be plus Q charge, and now there is minus Q charge here, and again because of repulsion the electron will move on to this terminal of the battery and there will be plus Q charge because minus Q charge is left. Okay, so this is how the plates have these charges. And now we'll move further. We'll see if this was not so, the net charge on each capacitor would not be 0. Okay, and you know the charges, the net charge in a capacitor is 0, so it proves that. Okay, because it has plus Q charge, minus Q charge, and the whole capacitor has a charge 0. We know that the net charge on a capacitor is 0. Okay, this would result in an electric field in the conductor connecting C1 and C2. Charges would flow until the net charge on both C1 and C2 is 0, and there is no electric field in the conductor connecting C1 and C2. Okay, so you see, when I had connected this to battery, then it has plus Q charge and it has minus Q charge, and there was electric field stabilized in between. Okay, now this electric field, because the effect of the electric field, the charges will move. Okay, electron will move in the opposite direction and it will be accumulated here, so there will be no charge on this connecting wire. The charger will move until there is no charge in this connecting wire. Okay, and the net charge on this is 0. I explained it earlier in a different way. Okay, so this can be one explanation now, but the thing is there is no charge on the two capacitor and net charge on the two capacitor, and the charge on each plate is plus Q and minus Q. Now moving further, we'll see thus in the series combination, charges on two plates plus minus Q are the same on each capacitor. The total potential drop V across the combination, the sum of the potential drop V1 and V2 across C1 and C2. Suppose these two capacitors are connected to a battery of V potential, then what will happen? The potential across these two will be divided V1 and V2, because what is potential difference is the work done or the energy per unit charge. Okay, so this will be divided among two capacitors. We'll understand it in detail in chapter number 3. Okay, so now this is, so you see the total potential V is V1 plus V2. So this is V is equal to V1 plus V2, where V is the potential difference across the whole circuit or the potential difference of battery, and the V1 is the capacitor voltage across the first capacitor, V2 is the voltage across the second capacitor. And now V1 is what? V1, you know from the formula of capacitor, C is what? Q upon V. Okay, so I can write V is equal to Q upon C. For the first battery voltage across first capacitor, V1 will be charge on the first capacitor, that is Q. Okay, and C1 is the first capacitance. Okay, similarly for V2, this will be Q by C2 by the same method. Okay, now yeah, so what I can do, I can also write V is equal to now I can just bring it on the, take out Q common and bring it on the denominator by cross multiplying. Okay, so V upon Q is equal to 1 upon C upon 1 upon C2, and this will become my effective capacitance. Okay, so now we can regard the combination as an effective capacitor with charge Q and potential difference V. Okay, the effective capacitance of the combination is C by Q by V. Okay, so now this will become the effective capacitance C. Okay, this will be 1 upon C because C is what? Q upon V. Okay, so this will be 1 upon C. So you see the effective capacitance is 1 upon C is equal to 1 upon C1 plus C2. Okay, so we can get this for the n number of capacitor. If they are combined in series, then what will happen? The effective capacitance will be what? That will be the 1 upon C1 plus 1 upon C2 plus 1 upon C2. No, okay, sum of the reciprocals. Okay, the reciprocal of the effective capacitance will be the sum of the effective capacitance of the capacitor. Okay, by the same thing, same way we can prove this. Okay, the proof clearly gets through any number of capacitor range in similar way. Equation for n capacitor range series generalizes to V is equal to V1 plus V2 plus up to Vn. Okay, that will be sum of all the potential across all the capacitor. Okay, then I can write a Q upon C1 plus Q upon C2, and similarly we can obtain this. Okay, so you see the capacitance in series combination is, the effective capacitance in series combination is less than the individual capacitance. Okay, suppose I combine capacitor of 1 upon 2, 1 upon 3, 1 upon, okay, I combine capacitor of 2 capacitance, 2 farad, 2 microfarad, 3 microfarad, 4 microfarad, then definitely the equivalent capacitance will be less than this. Okay, so where do we use this type of combination, this series combination? Where we have to distribute the voltage. Okay, where a large voltage is there, so there we use series combination so that voltage is equally distributed among the capacitor. Okay, to operate the capacitor, because if we operate the capacitor in high voltage, then it will stop working or it can damage. So we just use series combination so that the voltage is distributed and the capacitor runs without being broken or without being destroyed. Okay, I hope I was able to make you clear this topic. Okay, if I was, please like the video, share it with your friends who want to understand NCERT, and subscribe to my channel, hit the bell icon to get the notification. Okay, and thanks for watching.